All right. So we've got another situation where I'm trapped here in a bubble. We've got SI, temperature, and conversions. So SI has to do with the different units that we use in chemistry. So we're going to talk about those different units and what they are measuring. And then temperature is obviously about the temperature things are, and we'll compare and contrast heat versus temperature because that is our two objectives relating to that today. And then we've also got to talk through conversions and how that relates to temperature. So we're going to do this on page 27 here. So go ahead and flip over to page 27, get those objectives written out, and then we'll get started. All right. So we are going to begin first talking about SI units. Fundamental units are the ones that we deal with regularly, and these are going to be ones that are unaltered. So for length, we've got the meter. For temperature, we've got the Kelvin unit. We'll talk more about that when we get towards the end of the video with temperature. And time is in seconds. Mass is in the kilogram, which is a little weird because it's the only one that has a prefix, but that's the way it is. And amount is the mole. That's the amount of something. And we'll deal with that in next unit some more. Current is ampere, and luminous intensity, so how bright something is based on the candela. Those are the fundamental units in chemistry. So derived units are something that you start with one unit and you've done some sort of operation with it. So like area, you do length times width. So meters times meters gives me meters squared. So since that's derived by doing an operation, that means it's a derived unit. Volume is meters cubed, energy is the joule. We don't have to deal with that a whole lot, but technically that is meters squared times kilograms divided by seconds squared. Again, you don't need to know that. A little later in the class, you'll get familiar with joule, but you won't need to know what it is. Speed, meters per second or miles per hour is the one that we typically are familiar with, and then acceleration is meters per second squared. So those are derived units because we did some operation on them. Next, we've got some other units, so things like centimeters, inches, and feet. Those are all for length, just not the SI units for them. And then temperature is Celsius, Fahrenheit, and like you saw earlier, that is going to be connected to Kelvin, which we'll talk about later in the video. Volume, liters, milliliters, and gallons, and then speed is going to be miles per hour. So, what dimensions are used? Okay, so we're going to go back here. When I'm talking about dimensions, you're looking at the thing that you're measuring. So this is my dimension, and then whatever I'm measuring it in is the unit. Okay, so dimension is what's being measured, and what I'm measuring it in is the unit. So then what dimension is being used here? So this first one, we're looking at 8.5 kilograms. Kilograms measures mass. So the dimension it measures is mass. This is 95 minutes, which is time. We've got 4,000 feet squared. Since it's feet squared, that means that it is going to be an area. Squared means that it's measuring an area. Centimeters cubed is going to be a volume because it's three-dimensional. MPH is miles per hour, which is speed for miles per hour. And G per ml is grams per milliliter, so that's going to be a density, which is a derived unit, that grams per milliliter derived. Meters per second is speed. Okay? Make notes of any that you have questions about or that you're unsure of. Then density measured in grams per milliliter. You also need to know that 1 milliliter is the same thing as 1 cubic centimeter, so 1 centimeter cubed. And that's also on the back of your periodic table on that reference sheet. Also need to know that density of water is 1 gram per milliliter. You could also measure that in grams per meter, kilograms per meter cubed, or something like that, but it's just a different unit. You'd have to do conversions for it and that sort of stuff. What about pounds per foot cubed. Well, yeah, you've got a weight, which is our equivalent to a mass, and then foot cubed, which is a measurement of volume. So definitely would work also, but the one that we are going to be looking at is grams per milliliter or grams per cubic centimeter. So logic behind the temperature scales. You guys have seen Fahrenheit and Celsius before. Kelvin's a new one, potentially. But Fahrenheit, when they came up with Fahrenheit, they actually looked at the freezing point for a salt water solution and set that to 30 degrees, and then looked at human body temperature and said that that was 90 degrees, and then kind of went from there to make the rest of the system. Okay, so it's a little bit noodly. Not, I personally have trouble remembering that, and that doesn't really make much sense to me. Celsius, they took the freezing point of just plain water and said, okay, well, 0 is easy to remember, so let's make that 0 degrees Celsius, and then let's make boiling point of water. Let's make that 100 degrees Celsius. So that's going to be easier to remember. And then Kelvin does the same thing with water being the thing that bases it, but it is going to be 273 lower than Celsius. The reason is because Kelvin wants 0 Kelvin to be the lowest possible temperature. Okay, so that's the thinking behind those 3 sets of temperature scales. So we need to be able to kind of talk through that a little bit. So temperature, water boiling, only water, is 212 degrees Fahrenheit, 100 degrees Celsius, and 373 Kelvin. Okay, so those are boiling water temperature. Then freezing point for water, only water, not mixed with anything else, is 32 Fahrenheit, 0 degrees Celsius, and 273 Kelvin. Notice there's no degrees on the Kelvin. Since we're on the topic of temperature, again, that objective that we've got wants us to be able to compare temperature versus heat. So temperature is the measurement of the average kinetic energy. So it's the average kinetic energy of the particles in the air. Okay, so that's the measurement of the temperature. Heat has to do with how fast particles are moving. So heat has to do with the speed of the particles, and the temperature has to do with the average kinetic energy. So that's the difference between those two. And when you increase the speed, the heat, that usually means increased temperature. But if you have few enough particles, then that may not be the case. So average kinetic energy is temperature, the average moving energy of all of the particles, whereas the heat is actually just how fast each of those particles are moving. So that leads us into temperature conversions. So you see right here formulas for calculating either degrees Celsius or degrees Fahrenheit if you have the other. The one that we're going to focus predominantly on is being able to convert back and forth between Kelvin and Celsius, because those are the temperatures that we are going to be dealing with in chemistry. So you will actually find Kelvin equals degrees Celsius plus 273. That's on the back of your periodic table, and you're always going to have access to that. So let's work a couple of problems real quick. Okay, so first we've got 15 degrees Celsius, and we know that Kelvin equals Celsius plus 273. So I take this, plug in here, and I've got Kelvin equals 15 plus 273. Whenever I do that, I get my Kelvin temperature is 288 Kelvin. Okay? Then in contrast, if I start with 298 Kelvin, I've got Kelvin equals Celsius plus 273. Plug in my Kelvin temperature, and because I have my Celsius over here with the plus 273, I've got to subtract 273. And that gives me 25 degrees Celsius. Then 37 degrees Celsius. If we've got 37 degrees Celsius, we're going to plug into my formula here. That's going to go Kelvin equals 37 plus 273, which gives me 310. One more, and then I'm going to give you guys 3 to work on. So last here we've got 200 equals degrees Celsius plus 273. I'm going to have to subtract 273 from both sides. Because I'm doing that, I've got negative 73 for my degrees Celsius. Okay? Go ahead and pause video, try the last two, and then check those. Alright, welcome back. I'm going to clear, and you should get as your answers here 150 Celsius should be 423 Kelvin. 373 should be 100 degrees Celsius, and then 0 degrees Celsius is going to be 273 Kelvin. Okay? Make note of any questions you've got there, and we will check that. Then the last thing for us to talk through is, remember, for metric prefixes on your reference sheet under unit conversions, you've got all of the metric prefixes there, so you can reference that. That'll be important for us, especially going into that next video. Okay, so in summary, SI units, make sure that you've got derived units and determine the types of units and be able to determine the dimension that they measure. Temperature conversions, metric prefixes, be able to know them, and then go ahead and you guys get started on the practice. Make note of anything that you need to ask me a question about, and thank you guys so much.